So, good morning, everyone. Good day. Today, we'll be going through the last class of Module 4, which is class 10 for advanced topics in cryptography, and specifically going over zero-knowledge proofs, which is one specific advanced topic that has a lot of interest recently in the Web3 space for scaling, blockchains, and also for privacy. So on our marmajit.org/NCR page, you can see information about the course. We went through Module 1 at the beginning, which was class 1-2, Foundations of Blockchain and Near, Methods for Blockchain Data Retrieval. And for Module 2, we had a couple of classes as well, going through data visualization techniques and data transformation. Talking about ChatGPT a little bit, how you could use EasyPull for on-chain data, and then use a tool like ChatGPT. There's many AI tools out there, but T4 is a pretty good tool that's available for most people and allows you to kind of chat back and forth with data that you might have got on-chain through an EasyPull or through just data you found on a Block Explorer. Class 4 went through advanced data analysis techniques, and we use AI for this. Jeff came out, talked to us about some AI tools you can download directly onto your machine. You're taking data from a dashboard about your account or about a DAO contract or a smart contract. For example, maybe you're talking about the Meta to empty DAO transition. You're trying to see how many accounts made the migration in time, how many failed transactions there were, how many Meta tokens didn't get swapped. That could be an analysis. Well, maybe you just download all the transaction data over the past 6 months of the transition period from NearBlocks, and then you just start talking to your AI on your machine about what data included. So in the month of May or in the month of April, how many people transferred, and start getting graphs for that data. Module 3, specialized topics, which we finished off last week. So we went through identifying our research projects, which I'll go over in a bit. But thank you. We have 11 submitted research projects so far. I've heard from some students that they still plan to submit, so that's pretty awesome. Thank you everyone for participating so far. Then we talked about governance and blockchain, and a lot of students, almost all the students so far have joined the DAO, the Research Collective DAO. Then we talked about decentralized finance, where students were tasked with trying to add liquidity to a farm and trying to, or add liquidity to a liquidity pool on Ref Finance, and then take those liquidity pool shares and deposit them into a farm. We went through non-fungible tokens and NFTs. I think a lot of the students got involved with this. The user experience flow on Near with minting NFTs is so straightforward and simple. A lot of students were using the Mint-based NFT creation link to create NFTs, and hopefully you were able to share that with some of your friends and family maybe, and get them their first blockchain-based Web3 wallet or account, which is pretty cool. They went through blockchain and gaming, where a lot of students, again, were involved with the Crypto Heroes game, unlocking their characters, going into the dungeon. I even saw some students at the Monday Marmajit Gaming community call, where they're able to get more loot boxes and hopefully advance further into the game. But today, for our last class, in the future, this will definitely be broken up into more in-depth topics. Now, we are still doing this at a pretty high level, trying to not be that technical, but give an overview. So if you're in a conversation with someone, or if you want to start looking into some of these topics, you know where to start, you know where to ask questions. So here you go. We're going to be talking about advanced topics in crypto and zero-knowledge proofs. So moving on to the actual submissions. So these are the submissions we have so far. If you do not see your Near account or your submission here, this is for week 5. So again, I can share these links so that people can look through. If you do not see your Near account listed here, and you do not see your topic here, or it's incorrect, or something looks wrong, please let us know. We will make an update. But these are the projects so far. If you're having maybe some difficulties with your project, or you want some extra ideas, please feel free to look at other students' projects, get some ideas for your own paper as well. I want to pick on Clara because I just went through it today. It's very well done for submission. Let's zoom in a little bit. So, simple topic, what we're doing here, why are we part of this course, why is this getting written? Researcher name, NEAR account, instructor, nice to have, not needed, but great to support the project. Title, and then I like, again, having just high-level subtitles for each area, so it's very easy to read through it, right? The question is prominent and forward. Can NEAR become a green oasis? Now, and the paper starts talking about what does green oasis mean? How could NEAR potentially be useful here? And explaining a little more of what is the refi revolution as a whole. And again, the subheadings make it very easy to walk through the paper. There's the use of like short paragraph, the use of excerpts and quotes, the use of bullet points and bolding to make it easy to skim through as well. If someone wanted to pretty much just read through maybe the headings, the quotes, and the bullet points, it'd be very easy to go, okay, why is NEAR good? Scalability and speed, user-friendly experience, and interoperability. And the extra information is just prove the researcher knows what they're talking about, so there's some background information, but arguably it's all there. And again, if someone was like, okay, well, do we believe all the information that's written? Well, potentially we can, because there is a link here. Now, I would suggest, actually, I did not check the link, so maybe a specific link to the docs might be more helpful. But I know this is, again, still a work in progress. There's 4 more weeks to work on these, but this is the idea. It's also climate neutral, and then you can, again, read sources to, how to find more about this information. Again, high-level subheading, and then, hey, there is a refi landscape already on NEAR. This kind of goes again to prove the question, right? Can NEAR become this green oasis? Part of the proof for maybe answering this is there is a budding refi landscape that already exists with a lot, again, instantly from my mind, I'm reading this, I see lots of information. It's a grower group. There's posts on the forum. There's DAOs. There's collectives that are all working on this. There's other projects trying to carve an offset. And there's Potluck, where I know I can do community funding, to find more projects. Open source protocol. So again, lots of things right away, and then you have your conclusion. And again, the conclusion is bringing up the bold, right? Scalability, user-friendliness, climate neutral, interoperability. We know this from the highlights we read. Then we see that there's the blocking and movement was already written in the paper, and then the answer to the question potentially. So growing community interests, all right, and development indicate a promised future. So the answer seems to be potentially, and then continued research and development would be useful to making sure that this this budding ecosystem, this promising future can be fulfilled. And then I did leave, I on most people's papers, I did say having a reference list is not 100% necessary. In my opinion, it's like 99% necessary. It's very, very helpful to the reader. You are going to have one. Always good to try and make sure it is organized in some way. So it's actually pretty nice having like the breakdown here, the double layered list. Potentially trying to have either alphabetical, which might be more useful here, just listing all these in alphabetical order, or listing them in the order that they appear in your paper. And we've had students do both of these in the class. Some students are kind of doing it in order from, this would be the first link, even though W in front, and so forth, right? This would be the second link, even though it's an N, and you go that way. So hopefully that's clear. One thing I did want to go over with the papers before we get into the rest of class is the way you talk about NEAR protocol, NEAR foundation, and NEAR community is arguably all a bit different. So here we're talking about NEAR the blockchain. So NEAR is climate neutral is meant to be a fact, right? We're not giving personality traits to the blockchain. We're just saying that there's been, it's a fact, a stated fact from the paper. There's actually been carbon offset calculations done, and so the blockchain is climate neutral. Now, if we tried to say that NEAR protocol tries to be climate neutral, that might be a little bit more difficult. Right? Now, we could maybe say the NEAR Foundation is in talks with organizations to certify that the NEAR blockchain is climate neutral. Hopefully that makes sense. We can't be adding, or it's not appropriate grammar usually, at least usually, to be adding personality traits for the blockchain. I mean, that's what's written here. I don't. I mean, I'll pick a random example because I think this was the one that I was looking at today. Sorry, no big deal. But here, this is an example. Near protocol actively works with other blockchains and interoperability-focused initiatives. Right. So let's just take just that sentence there. The idea of why this is potentially incorrect is because the blockchain in itself cannot actively do anything. Right. It's a blockchain that it's a computer program. It's just code, software. Nodes in the ecosystem are running this software. So maybe node operators would be making decisions, or protocol developers would make decisions. But the blockchain itself, not yet anyways, maybe with AI it might happen, but the blockchain itself does not actively work with other blockchains. So maybe the Near Foundation actively works with other blockchain foundations, right? And interoperability focused initiatives. And then you have a link to show, and this might be one. So this initiative, bringing IBC to Near, so we believe our joint effort with the Near core team. Right, so this is explaining that this is a joint effort between, I'm assuming, some Polkadot developers, right? I'll have to read it. The proposal can be divided into 3 main requests, pending Near community's approval, right? So this is like a proposal to do this. And it's the Near core team, and probably not without blockchain, right? It's the some Polkadot team, or maybe even a developer from the Polkadot ecosystem. But the purpose is, a lot of students were doing this, so I'm not picking on one person. But when you're talking about, so here, you're talking about something within Near's ecosystem, which makes sense. But so Near protocol's approach to cross-chain interoperability revolves around innovative solutions. Again, this is like borderline, where like if you said Ethereum's approach to cross-chain interoperability, technically Ethereum or Bitcoin, they don't have approaches to things. They don't have ways in which they want to do things. There is developers in the ecosystem that have built certain tools. So you could say, the Near ecosystem, Near protocol ecosystem, has innovative solutions and boasts strategic partnerships, positioning itself as a key player, right? Learning objectives: to understand the key cryptographic concepts included in blockchains, including hashing, private public keys, and transaction signing, like how that works. And from a high-level understanding of ZKP, zero-knowledge proofs, and what's their role in privacy, scalability, specifically looking at some other applications in Near protocol projects. There are 2 articles here. One of them, again, is like an older Medium post from September of last year, I think. Yep, September. Talking about, what are zero-knowledge proofs? What are some projects currently being built? So zero-knowledge light client to quickly verify transactions on the blockchain, or this is to verify between Ethereum and Near. Hide your cache, which is like a privacy use case. They have ZK bridges for security as well. A lot of other projects students can read through. Again, this is an article in blockchain moves very quickly. Some of these projects are not still building on Near. So I think it's a useful article to read through. It's, again, a 5-minute read, very quick read. Not going to take the time to read that on the class, but it does give you an overview of, okay, well, September of last year, it wasn't that long ago, but maybe 9 months ago, 6 to 9 months ago, what did the ZK landscape look like in the Near ecosystem? So useful article. And then this article, I think every student should go through it. It is a very, very, very good overview of zero-knowledge proofs and how they can specifically ensure privacy. So this is not going through as much of the scalability aspects, but it is interactive. You can log in with your Near wallet. So every student here should have one. You can log in with your Near wallet. You can start earning some tokens, right, for interacting and tipping. And as you go through the course, right, you can learn about ZKPs, how they follow certain criteria. The ZKP must follow 5. If you know just this, you will sound very smart in most conversations about cryptography and ZKPs. Right? It must be complete, right? The statement must be, if it's true, it should be allowed to be verified. It must be sound, which means there's no way you can falsify any of the information. If you say I'm trying to prove that I'm 18 when I go to a bar, well, first of all, if I actually am 18, then the bouncer at the bar should always be able to verify I'm 18, and I should have no issues with that, right? There should be no issue with verifying. If it's true information, I should verify it. It should be sound, which means if I should not be able to get a fake ID and that says I'm 18 when I'm not, right? There should be some sort of cryptographic proof proving that I'm the person giving the ID and that I'm actually above the age that can prove this information. Falsification must be impossible in ZKPs, and it must be zero knowledge. So if the statement's true, like I am above the age of 18, I should not have to give out the actual age that I am. So I'm going to a bar. If I'm above 18, there's no way I should be able to be turned away as long as I'm 18. There should be no way for me to falsify the information, which means if I'm only 16, there should be no way to say that I'm above 18 and get in. And let's say I'm 21, there should be no reason that my actual age of 21 should be leaked, right? All the bouncers should know is that I'm above 18. So that is a zero knowledge proof. There you go. You've all learned something. You can all go somewhere and explain zero knowledge proofs and be like, this is what it is. Now, how it works might be a bit more complicated. We'll get into that. But it'll have a quiz to take you through that. So all of the above. And it'll go through a bit more of the technical sides of it. You don't understand all of it, but I would suggest at least going through the quiz. It teaches you a lot of basics, and to be able to talk to other people in public about, what are some projects that use zero knowledge proofs? So now you'll know there's 4 projects that use ZKPs. You'll know how they work, and you'll know the paper that started it all in the 80s. Right. Number 3 is the study of integers and the relation between them. So basically the study of numbers, 1, 2, 3, 4, 5, right? And how they relate to each other. Basically patterns in numbers. So mathematics is the queen of the sciences, and number theory is the queen of mathematics. So you study regularities, which are independent from the universe that we live in. Very messy stuff. Very abstract ideas of mathematics. Well, the goal of the article is to understand how to construct linear one-way functions using finite groups, which have a certain property. That makes it sound so simple, but the idea is this is how we're doing encrypting and decrypting information, which is the basis behind cryptography, the basis behind cryptographic proofs, hash functions, for example. So if someone says, "Oh, can you send me your transaction hash?" Right? They're talking about a linear one-way function to hash certain data. Right, which gives it a certain property, right? That's why a hash is always deterministic. So let's maybe show an example that everyone should know, right? When you do near blocks, there is a hash, right, of this transaction, and that includes all the data from the transaction. What deterministic means is that this hash right here, GE5X UD, will always be this information here, right? It'll share that this account sent information here. It's someone claiming hot tokens, and that'll always be what's in this hash. But how do you actually create that hash? How does a blockchain function to you? So on near, again, I'm going to try my best not to go through too much of this article. It's very convoluted a little bit. But there is a area where we're trying to get to. So everything before notation should be read by every student here, maybe not the citations, but all the way from the preface, outline. You can skip contributions, fine. This is the section I actually wanted to go through. It should be no surprise that an article about math contains lots of math. If you're afraid of math, then see this article as a free exposure therapy session. So I get it. Not everyone likes math. You will have to at least read math here. But number theory is quite different from the math you probably did during high school. Number theory is mostly about understanding why certain properties exist and patterns exist within numbers, within groups. So you're not going to ever have to really calculate things yourself. You'll have computers to do this. So usually what you're doing is you're using computer programs to calculate different properties, and then evaluating those properties again with computer programs. So it's a bit different. To understand what's happening, you do not have to go through all of number theory, elliptic curves, finite fields, prime numbers. As long as you understand what a linear one-way function is, you'll have a very good understanding of how cryptography works. So we're going to try and go through at least this part of it today. And again, if students want to dig deeper, they can do so on their own time. Again, I don't want to go too much into the weeds. This gets very complicated very quickly. A linear one-way function is a function. So, talk about functions on the protocol blockchain. A function maps inputs from one set to outputs in the same or another set. Usually, you have functions that have logic on a smart contract that we're used to, right? We might have a DAO contract, and on that DAO smart contract, there might be a transfer function, right? Or an add proposal function. Now, that add proposal function, you're going to have to give it some inputs from one set. So your account name, you're adding a proposal. What type of proposal? Is it a joint DAO proposal? And the outputs might be in a different set for a DAO, right? The outputs would be adding the proposal to the DAO and allowing people to vote on it. In mathematics, functions are always deterministic. So if you have 1 plus 1 in the inputs, you have 3 in the outputs. Those are different. Well, they're technically both in the same set of numbers, right? Numbers from negative infinity to infinity. They're both in the same set, in that sense. But you're mapping inputs to outputs in the same set. So if you write the function of A equals A, that's always going to be the truth. F is the function, A is the input, capital A is the output. Okay, so we're not getting too complicated yet, hopefully. We're keeping things somewhat simple. F is for the function, the little a is for the input, big A is for the output. Okay, it's all right here. Should be relatively straightforward so far. Now, one way, which means we're going in one direction. Okay, so some functions are not one way, they work in both ways, which means if you have, let's zoom in a little bit so it's easier to see. If you have this hash function as an output, two-way means that just with this output, you can get the input. That is not how hash functions work. A hash function works by saying, as long as you have this input, you can get the output. Might be getting a little confusing now, but that's okay. Basically, the output, remember, the big A, which you get from the little a, at least is inefficient. Not impossible, right? In number theory, nothing is usually impossible, just really, really inefficient. So when we talk about the fact that it's difficult to hack blockchains, it's difficult to break the cryptography behind blockchains, what we're saying is it is very, very, very inefficient. And why blockchains are so useful is because this inefficiency can be calculated with an actual dollar value, right? Because you can take the actual dollar value of near, right? And you can actually calculate the cost of breaking this one-way function. You can actually calculate the cost that it would take computers at today's rate to do the math, to break the function and hack the blockchain. You can actually start saying, okay, it might cost, $1 billion to hack Ethereum or $10 billion to hack Bitcoin. And so a lot of people invest in these technologies, not just because they see the price going up or the price going down, but it's because they can actually calculate the risk and calculate the security behind the blockchain with this linear one-way function. That's a simple way of putting it, I suppose. But basically using this example, taking this data from the transaction and getting this hash is very, very quick and easy. But taking this hash and trying to get this data is very, very, very difficult, would be the idea of a linear one-way function. It doesn't mean that it can only go one way. It means that it's very, 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 very difficult to go the other way. Linear, restrict the function of our input to integers, numbers, and there needs to be an operation. It gets a little more complicated, but you just have to satisfy mathematical notation. I'd say just, but there's an actual graph for it that if you look at it for like maybe 10 minutes and read this a few times, it'll make a bit of sense. Again, it's just a pattern. They're basically saying it must be a function, it must be one way with some sort of this inefficiency included, and this pattern. And this is what gives you the beauty of cryptography. What is a cryptographic primitive? With a cryptographic primitive, you're using these basic building blocks that allow these low-level algorithms that are used to build more complex algorithms, right? So just you might want to build a house, right? What you actually want is the house, a place to live in, a place that's secure, a place you can run events and sleep at night and lock the door, right? These are all the things you want. But the actual primitives are the building blocks. Like when you're building a house, you don't need to build everything from scratch, right? You don't need to build the door and cut the wood from scratch. You're going to go buy that building block from maybe a carpentry store that specializes in that. And then you want to get a lock for that door. If you're making a door, it does not come with locks usually. You'll go to a specific locksmith, right? And you'll get that specific building block from that specialist. You'll put it into the door. And you might have a smart home system and a security system. You might have plumbing systems, toilets, light fixtures. All of the primitives, right, come together and allow you to build these, these algorithms, right? These higher level algorithms, these higher level pieces that are put together, right? So hopefully that makes a bit of sense. But to maybe make it more technical, you might have a application, right? The video game that needs to use some sort of randomness, right? There needs to be a random number generated to see who's going to fight first in the battle, or to see what's going to come out of your loot box, right? Well, the random number generator is a cryptographic primitive, right? There needs to be a verifiable way a lot of times to prove that that number has not been leaked before, or else you can cheat in that game. So there's lots of ways in which you can use cryptographic primitives to, for example, hide that number after it's generated. Have a proof that the number was generated within a set, where we talked about completeness and soundness. So we can prove that the number exists and that it can't be changed. We can prove that as long as the number that you choose the correct number, we can, or someone can't lie and say they chose the correct number, and we don't have to actually reveal the number, but we can prove that someone got the number correct, right, in this scenario. So again, the article goes through why these primitives are important. They're important for security, for encryption and decryption, for validation, and they're helpful for these tools because you don't have to build them from scratch, right? The reason they're secure is because they've been proven, other people have used them, and those people have been hacked, and so now you can use that building block, right? Here, I just get a little bit help to see the different types. So again, we have one-way functions, one-way hash functions. We have symmetric key cryptography, right? So that's where the same key is used to encrypt and decrypt the message. This comes with security concerns, potentially, right? Because the same key is shared between myself and the other third party. So if I want to interact with the bank and I have all my assets in my account and the bank has a key, well, the bank can keep all my assets secure, but the bank can also read all my data and move all my assets because the bank has the same key that I would have. So this is not very useful for open, decentralized systems, but it is still cryptography. It is still keeping a message private only between two parties. And this is still used in many, many areas. For example, you might want your computer to be able to talk to a different device you own, like your phone. And so maybe in this instance, you want a very lightweight cryptography scheme, or a primitive that's very lightweight, because it's okay if the same key is shared between two devices that you own, potentially, right? that's an example. So Internet of Things devices might use this, right? If you have a phone, a laptop, a fridge, a smart speaker, and they all need to share a key together, that might make a lot of sense to use symmetric key cryptography. Now, asymmetric key cryptography is what we're more used to in blockchains. This is what allows us to sign a transaction on a smart contract, allowing that smart contract to know that it was us, right? It can verify that only Chloe here could have signed this, because you're adding data that only the private key owner would be able to add. So with asymmetric key cryptography, so also public key cryptography, there's a public key and a private key, right? So you have usually one private key. Now on Near, I know there's multiple private keys, so it's not that you can have multiple private keys, but the idea is there's a private key and a public key. The public key is known by everyone, and it's included in the message. And the private key is only used by the owner. And if you're going with or older systems like DSA and RSA, which are just older encryption schemes, in which, yes, you would use your public key and private key to sign. Everyone can see the message, but they can't read it unless they have the key. And then whoever has this key could still unlock the message. But again, you could have different keys for different, this gets a little more complicated than this as you get into like Ethereum and Bitcoin and the like. I did want to give a bit of an example on Ethereum though, because on Ethereum, it makes it very easy to understand how this works. So most people have seen MetaMask, and most people have seen how on MetaMask, you have one private key that you will secure, right? And we don't have to ever show anyone this. We're on the Ethereum mainnet. But when I want to add an account here, I have a bunch of accounts, right? Account 1, account 6, account 7, account 3. If I want to add an account, right, I'm not going to be adding another private key. It's going to use my exact same private key. It's going to use that to generate a public key that is deterministic, right? It is always going to link to my private key, right? So here you go, account 8, create. This new account, 0x, I just see someone unmuted. Feel free to unmute and ask or type it in the chat. But just to finish the thought, this public key, 0x5, hopefully it can be CD, is attached to the same private key. So let's say I no longer want to associate with account 8, this 0x5D. That's okay. I can still use my same private key as long as it's secure, and I could retain somewhat privacy, right? I can retain privacy by just opening up a new account. There's almost infinite, well, not infinite, but an almost infinite amount of accounts, private keys. Remember, they're not really accounts, they're just private keys for the most part, right? So there's an infinite number, almost, public keys, that you can derive off of one private key, if that makes sense. So basically, when you open up a new crypto account, right, what you're doing is you're keeping a private key safe, which allows you with elliptic, so you're not really using elliptic curves, right? Using asymmetric key cryptography anymore. You're using, and this doesn't even talk about this. The article is a little bit like simpler. But when we look through Near protocols, this is the Near protocol docs. You can see that this is an elliptic curve. These are signing methods. So I'll open this one specifically. This is a Rust library. So this is for fast and efficient Rust implementation of this key generation, signing, and verification algorithm. So anyone is, curious about how Near specifically, what they use, what language they use. So it uses some asymmetric key cryptography. So these are all primitives, right? So primitives that are used, not all the primitives. Some of them are. I think randcore gives a random number, right? That's a primitive. ASM is giving you operations for another cryptographic operation. primitive. Another primitive, right, for serialization and deinstallation of private keys. So as you can see, there's many primitives that are included here, and they all come together to make this cryptographic tool, right? This is how your near account is generated. So when you want to create Chloe.near, you are using this to generate private keys and public keys. When you want to sign a transaction, you're using this. And when someone wants to verify your transaction was signed by you, this is the actual cryptographic library that's used on Near as well. So the question in the chat is, in theory, it's simple to have access to a message using the public key, but application is complex, even difficult with the 256-bit encryption that's currently used. So what I'm assuming you're saying here is that, like, the theory of how you would break an encryption scheme is well understood, but the actual computational power to do so, yeah. So the best example I have of this is that Bitcoin, for example. So basically all Bitcoin is breaking an encryption scheme, right? It's finding the answer to, like, the one-way hash function. So in Bitcoin, you're pretty much saying that there is a one-way hash function that's very difficult to break from. But can you break it? Can you find the answer to the question with all these zeros in it? And so, like you said, it's simple, right? You have lots of Bitcoin miners and the code's updating all the time. The process is well understood. It's simple, but then not everyone actually finds a Bitcoin block. So the complexity is high. If I use my laptop that I have right here, and I try and compute this function, right, to try and break the hash, it'll take me, I think we can Google it. Maybe I'll actually chat GPT it and we'll see what it gives us. So to follow along with Will's comment, right, for the complexity, it would take about 47,000 years, okay, for this computer or a typical laptop to be able to solve the equation. So this, in my opinion, Bitcoin does give a clear example of why we're saying it is computationally infeasible, right? With the computer power that I have at my disposal, it is infeasible to solve this equation and get the answer, right? But the entire blockchain revolves around getting that answer. And so I love Bitcoin for the reason that it takes the basics, the very first thing you learn in number theory, and it pretty much takes it to the extreme. And it says, well, to hack Bitcoin, we have the best computers in the world trying to get a Bitcoin block all the time. And what it actually does, if someone had computer power in order to break this, like quantum computers or whatever else, to solve the equation faster, you would know almost instantly now, because someone would have all the Bitcoin very quickly, right? To be able to solve the equation themselves with their own computer every single time. And so the reason that we know that cryptography works is because of Bitcoin, is because, you know, we understand that people are answering this question every 10 minutes. Like Bitcoin, I never show Bitcoin usually in classes, so but I think Bitcoin is amazing for its history and for it. So basically, let's see, yeah, about every 10 minutes usually, so it only took 6 minutes, right? This one here took a bit longer, it took 15 minutes. This one took about 9 minutes, right? The one before that only took 5 minutes, right? Every single time that a block has happened, somebody has actually broken arguably, right? They found the answer to the equation. So I'm gonna move on. I can talk about this for hours. This is the block with all these zeros. So basically, and technically, okay, fine, they didn't answer the full equation. They only have to find a certain amount of zeros in the beginning. So technically, Bitcoin could exist all the way until there's zeros all the way through. Every single zero that's included a huge jump in complexity. So to be very clear, Bitcoin is not going and breaking the entire encryption scheme. That would be very insecure if that was the case, right? But what Bitcoin does is say, how many zeros can you find in a row in the hash, which is already so difficult. And so if you ever saw Bitcoin hashes, you were getting to around here one day, it was all zeros till about here, that would be very insecure. That would mean that somebody might actually get all the way to the end and actually be able to crack the entire encryption scheme used. By then, you'd assume you could just, some people would say you could just double encrypt it, which would argue make it, well, not really if you break the encryption scheme, but anyways, that's not part of it. Sometimes if you use I think Bitcoin only uses 32 bits, and so you could use a 64 anyways. Not gonna go there. I will share this article. It's similar. It goes through a history of ZKPs, goes through a lot of the same information as the Near Learn Club article. I like that it gives more of a history. Again, talking about the paper that started it all, talking about some schemes that came out, some zero knowledge proof schemes. One of the largest ones, in my opinion, was zero knowledge Snarks. Instead of using Snarks, they use a different proving scheme completely. And like Starkware, Gods Unchained, that's all in the Stark ecosystem. And there's some examples of how to explain it. This level 1 explanation is probably one of my favorite for Where's Waldo. It's generally an example you can explain to someone that never heard of blockchain before, but you can still explain cryptographic proofs by saying, okay, well, if I'm playing Where's Waldo and I find Waldo, but I don't want to show my friends where Waldo is, but I want to prove that I found him, maybe that's so I can get the first place for me. It's a competition, who can find Waldo first. Well, what I can do is I can cut out a hole the size of Waldo. I can put my piece of paper, I can put that paper over top of the Waldo page, and I can show that to someone. Being like, okay, I actually did find Waldo. Look, Waldo's right there. But they wouldn't actually know in the entire image where Waldo was. So I'm not giving them the coordinates. I'm just proving that I found Waldo. And there's no fake that proof. There's no way to get the piece of paper and put it in the wrong spot and fake it necessarily. Now, I could potentially change the scheme and put Waldo in the wrong spot and do that. That could be a way to hack it. So it's a very simple example, of course, but that's the idea of how a zero knowledge proof works. I submit the proof that's quick and easy to verify and doesn't require me to redraw the entire page to show I know the information. That's kind of a zero knowledge proof. So this article will give you a few different examples. They're not all that amazing, but in my opinion, the first one gives a pretty good example of what zero knowledge proofs are. So the article I kind of already linked to, the KPs in here. So next steps is just going back to class 5 homework, making sure you keep working on it, making sure you use the next 5 weeks, June 5th, to submit your assignments. For the homework, we're going to be going through cryptography in practice, right? So the first one is very, very, very simple, okay? You're going to go to Near Blocks or maybe Pikes Peak. You're going to find a transaction that you care about a lot or that's really cool to you. So, if I go to, this is going to be difficult because I have so much random stuff on here. Let's try and find a fun one, maybe. I thought a fun one might be an NFT, for example. Like maybe go back to like one of the first NFTs you got. I think it does show the NFT as well here. Let me see. Viewing NFT transactions. Sorry, let me close. This could be a good way to do it because it only lets you see it on the actual contract. Sad times. Thought it would let you see the NFT while you're here. Token transactions there's too many transactions, 6,000 of them. But I can go to the last page, for example, and maybe it might be fun to look at like the first time that I farmed some Marma J. What's a fun one? I was gonna try and find like years ago, like something near at like $20 would be fun. Like sending one wrapped near. Anyways, here's one. Sending some tokens to a friend. I sent some ref tokens to a friend. This is my transaction hash. that's my little story. 2 years ago, I was onboarding a friend. I ended up spending then 21.19 ref tokens, probably from my rewards, to teach them about, I think they're writing a blog post actually on XREF and how to use it. And so that's what happened. So the homework would be share your transaction hash on the blockchain operating system. So what I put here is if you can go back and find where you claimed your NFT, that would be a great one. If you can, and not everyone might, it might take a while for some people. So I also said if that's, not the simplest thing, any other significant memory on chain that, is cool to you, feel free to share it. So for me, I just found a transaction of sending some tokens to a friend. So let's go to the overview. You can share the whole link, right? So we can go to Near social, what's happening, couple years ago, I sent some ref to right, and you just send that. Now, of course, you can write more information about it. You can tell a little more of a story. Feel free, post that. Feel free to share that in the homework thread, right? It'd be great to see what everyone's kind of a cool memory is. Maybe it's the first time you interact with DeFi. Maybe it's your first NFT drop from one of the homework sessions. Maybe it's joining your first DAO, like the Research Collective DAO. Maybe it's whatever you like, gaming, whatever else. Or it could be homework from this week. So the next homework assignment will be to visit OPAC tickets. Okay, the link is still hide your cash, which is interesting. They must like the link. Sorry, I am going to drop the link in the thread for those that want to just follow along right away. You will need to join the allow list and connect your wallet. So let's see what wallets here. I'm not even sure what I have. Okay, NCR week 10. Log in, let's say with Meteor wallet. And so hide your cash is kind of as it sounds. It's a mixer, right? Using zero knowledge proofs for privacy on the Near blockchain. It allows you to log in. It allows you to join their allow list. The allow list is so that they do not get in trouble with the SEC. So for example, with Tornado Cash, the developer for that, or one of the main developers, still in prison from my understanding. They said that he was helping, I think, North Korea and other known terrorist or sanctioned groups to move money through their platform. I don't know whether it's true or not, doesn't matter. The point is that a lot of platforms now have allow lists, which means that, if a government says that, okay, Chloe.near is a known terrorist, you cannot, send mixed transactions to them or private transactions to them. What this platform can do is keep private platform open. They can remove Chloe.near from their allow list. Now, is that very helpful? Maybe not, right? Maybe I can open up a new account, or maybe I can open up, please send me money.chloe.near, right? There's some ways to get around that, but this is the middle ground. If you're asking like, why am I joining this allow list? That is the middle ground. Now, I don't know if I'm on the allow list yet. I don't have enough near in here though, so I'm going to quickly send one near to this account. I'm going to test on a different account. Might as well just do it here. Got to keep these test accounts more full, apparently. You need at least one near. You can do larger amounts. What this does is it deposits this amount into a smart contract to privately, and then allows you to use a token to withdraw it privately as well. Maybe I'll just log in with a different, I'm just going to log in with a different wallet. Sorry, Near's down again. Every time we have a class, every Wednesday apparently everyone should be shorting Near on Wednesday. But yeah, the price of Near changes quickly. The RBC nodes have a hard time keeping up, it seems. Hopefully we'll get to the rest of the work relatively simply, but we'll see. Having quite a difficult time at the moment. Okay, we're still logged in. Yeah, I'm even getting an error saying I'm using mine. I wish I could show this. Actually, I'll take a screenshot. I think it's really funny, actually. That's a funny one. So you could tell you guys might see this yourselves in the future, trying to do things on Near, whether it's, Um, but what's generally happening is the RPC that's being used is overloaded. And so the website is trying, so Meteor Wallet now is taking so long because the wallet will try every few seconds. Like, oh, we're trying to send a transaction. The RPC node is overloaded. Let's try again. Okay, it's not working. Let's try again. Okay, it's not working. Let's try again. The problem is that some clients will actually stop after a while. My Near Wallet does stop, even though it's managed by the same team as Meteor Wallet. They do have a different process. Basically, stop with spam. They don't want every single person to keep retrying forever. But obviously, if you don't try forever, it stops after a while, and then you got to make sure your transaction went through. So this still might take a little while, but once we get through, we will be able to join the allow list. And then while we get started, though, everyone in the course, if you could please drop your NEAR accounts if you would, well, if you'd like to complete in the homework without using your own NEAR tokens. Now, for the homework, you will be able to get your NEAR tokens back. So I will show, once we log in, how that will work. But you will be depositing one NEAR, and then you'll be able to use the ticket you saved to withdraw the NEAR back. So again, that took a long time because it basically couldn't get the transaction through to the NEAR blockchain. You can get around this by running your own RPC node. So if students here are more technical, I would suggest potentially just running a virtual server and just running a node yourself and pinging that, because you could choose where the node runs. Like say you're from Europe, you can run the server in Europe, have a very quick connection time, and it would never get overloaded because you'd be the only person, or maybe you and your DAO would be using it. Anyways, we're going to deposit some NEAR, one NEAR. It's saying because you're only depositing one NEAR, you're going to have pretty high anonymity, right? The set is large. For 10 NEAR, okay, the set seems large, and for 100 NEAR, I don't have enough. So now the first thing you have to do is apply to the allow list. Hopefully this doesn't take too long, but it is another transaction. Okay, it should, right? It's trying its best to load the information. It'll only try 5 times though, which is the problem with my Near Wallet. I would suggest most students try and keep with Meteor Wallet for now. The Meteor Wallet will try and exceed the 5 attempts. My issue is that currently on my mobile, I use my Near Wallet, which is causing the same issues. And this might just cause too many issues. And I see no one adding their Near account name, so that's fine. I can keep the Near. People can try by themselves. There we go. It didn't load yet, but it knows we have enough. That's great. And all this transaction is doing is the function is allow list, and it's adding socialgood.near to this allow list. Lord help me. It's gonna keep trying. Once we are done, we'll be able to deposit and withdraw. But I do find it quite interesting how unusable Near is with a small change in price. But the RPC is so overloaded that I might not be able to, it seems, continue. Let's try one more time. Let's go back to Meteor Wallet. Maybe it is just better to try our best. Done this way. For some reason, Hot Wallet also seems to have an issue with the same. I thought they had their own RPC node, but every time I try to use Here Wallet, sorry. So Meteor on this wallet, even though it's overloaded, should just keep trying. This might have worked eventually. Okay, well, I've given up, I think. This has been quite difficult. Right, so on Meteor Wallet, though, you can see how you didn't even really notice that it was taken. And that's because it was retry in the background as many times as it needs. Seems like Here Wallet is working at the moment. Okay, so we are good to go finally. Okay, so let's apply to the allow list. Apply now. Again, Meteor Wallet should be able to manage, even if it's taking more than 5 attempts. So Here Wallet did work as well. So it seems like Meteor Wallet and Here Wallet both. So Meteor Wallet still taking a while, Clear Wallet went very quickly. So Clear Wallet does seem to have their own RPC working at the moment. Whereas Meteor Wallet seems like the RPC is overloaded still, but they will retry more times. So this can be a good reason why the students, you might just use either different accounts in different wallets, which I try and do, or just the same account in multiple wallets, which also might be helpful at times like this where, you know, Meteor Wallet's barely working, Meteor Wallet is working but takes a long time, and then Here Wallet, for example, is working quickly, but that'll change. Okay, I think it already did it. I'm gonna try with project. Sorry, I do like making sure I go through all of this, just because you guys as students are gonna have to go through the exact same process. When you go to it, refresh the page, it's allowing me to deposit. I sent the tokens over now. Okay, it will automatically download the file to your computer. Now that could be a security risk in some respects, but you know, that's fine for the homework, it's fine. You're gonna copy this, okay? Do not lose it, okay? If you lose this information, you will lose the data. Like you will lose the 1 near token. So to be very clear, trying to be, you know, open with students, you can drop your near account. Sorry, you can drop your near account, and we can send you 1 near. You can try it yourself, get your near back, but you will need to keep that key, okay, that private data. That is what you're going to be using. So right now we're creating a proof, and this proof allows us to withdraw the funds. Now what you can do is you can send this proof to someone else. Right? So what I can do now is I can take this information and I can send it to someone else, and they will be able to put that information in, go to the withdraw section, okay? So it's still saying, OPAC tickets need to download security file. OPAC tickets is downloading their side of the proof. Okay, we have 1 near account drop, thank you. We will add that. I'm gonna copy and paste so it's easier. We're gonna add you to the multi-sender. Here we go, 1 near. And let's see. It seems like everything's taking a while at the moment. Okay, so I will, since you were the first person to share, but I'll just show how you can do it to yourself. So if we do ncr week9.near, you will be able to check your account name, and it'll say, okay, there's not much anonymity because, you know, you just put it in. There'll be a small fee, and you'll lose tiny bit of near, but you can withdraw. So, and relatively straightforward. All you need to do is take this ticket and do so. So that is the homework assignment. And then the idea is to then, you know, document your experience. So there's UX experiences, right? That makes it a little bit difficult at times. For me, there was trying to find which wallet to use, the RPC is overloaded, you know, potentially misplacing my ticket for a bit. But yeah, I will get the rest of the account names. Nice try, Nedlar. Appreciate it. Wahaha. Okay. Okay. Just 2 people. Awesome. Okay, we're gonna send the 1 near. You can say show fees. You can see, I think it's interesting. Platform fees actually are quite high. It is based on a percent, it seems, on the amount, but the contract does need to do some work, so it's fine. We're gonna send 1 near to each of these. Oh, there's an extra one there. Oh, we have 1 more person, so that's fine. Oh, now we're getting them flowing in. Look at that. Woo! 1. Yeah, no worries at all. Don't worry. I'm sorry for taking long to get through some of this. Okay, so we're gonna multi-send. It'll tell you how much total near is being sent. There'll be some data here. You can read through it. I would suggest you do read through it. Gosh, now we're back here, and we will hopefully how it should work now. It shouldn't go loaded for that long. But this will hopefully go through simply. Wow, that was so much quicker. Look at that. So now all you have one near, which you can then ZK snark. This is not a snark, but a snark. Proof has been successfully generated. Please click confirm to initiate the withdrawal. So if you've gone through the homework, withdrawal error, apparently. Well, that's not good. Let's see if it didn't work. I don't think it did work. Let's see. Near blocks. NCR weak and near. We deposited out. Let's try again. Find it from here. Okay, open this. Let's see. Okay. Week 9 here. It checks the address, and then the error it gave me was actually quite weird. The way I had to like say which registry we were using. I don't know why that would make a difference. But anyways, it shouldn't have an issue with that. Maybe it wasn't generated quickly enough. So let's try it again. These would be all things that you add to your experience of using the platform. And again, you might run into some difficulties, you might have some feedback you have to provide, but that's why, this time it just didn't like the page at all. Let's try that again. Stop the page, again. Okay, withdraw, paste the ticket. Take your time downloading OPAC. NCR, week 9, near. Okay, apparently it's still downloading stuff. And so I would be somewhat wary, again, of using this platform for an actual use case. If you actually wanted to secure your finances or make it private transactions, it might not be the most efficient. But I do think it's valuable to go through the process, try to understand how the proof is being generated, learn how to keep that ticket safe, be able to withdraw. But I think it's trying to use the browser to do stuff. So maybe my browser stuff is causing me to have a hard time. Maybe one more time. And then maybe I'll give up for now, let you guys go on your way. And then one of you students will probably get it before me and you can send a screenshot or something in the chat. But I will try one more time on the call, and then we'll leave our feedback for OPAC, saying I did this, I tried, and that made feedback as well. I got one error, and then from there couldn't get it to download security files. Week 9 here. Okay, so it seems like it is pulling up the account, that is working, but it seems like this part is having a hard time. And that's probably why I got the error last time, where it allowed me to withdraw, but it said you need to choose your registry. I don't see why that would even be necessary, to be honest. That's probably automatic. So pretty easy to see, where my deposit came from. Where it checks if I'm on the allow list, because I am. The secret hash instead of information. but it does check ncr weak.near to see if we're on the allow list. And it does show the attached deposit. But it doesn't let you know that you're connecting the withdrawal. Okay, perfect. We got there. I might give it a few more seconds just so that whatever happened last time, maybe it doesn't happen again. But yeah, let's try to withdraw. It should not cause an issue, but again, maybe it's moving so slowly that maybe it's having an issue connecting to near as well. Maybe their RPC is overloaded. It's kind of hard to know the exact issue. I'll try and if I see the issue again though, I'll screenshot it this time. Let's go, it worked. I'll give it a few more seconds again just to make sure. Safe information, but maybe still stuff's happening in the back end. Because last time that seemed to happen where it said things was happening, but they weren't. Okay, confirm. Come on. Oh, see again. Print screen. So specify correct relayer address. But that doesn't make any sense. It's not for the user to do. That's for the application to do. Very interesting. It seems like there is a bug. So for the students that did get the 1 near, feel free to test it because it's class near. You can see it worked for you.